Hi everyone. I'm going to show you a video and the steps of demo 2 constructing product life cycle. Okay, so before I start the exercise, let's understand what we are going to do. So in this case, what I'm showing you on the screen is the life cycle of a shade. So we are going to do an analysis of the life cycle of the shade. So if you look at this life cycle of the shade, it was made from a wood plank and then also from steel as the nails. And then this wood plank is to be extracted from wood from the forest as raw material. So to make 1 unit of a shade, we need about 150 kg of plank and then 2 kg of nails. And consider there is no packaging. So after this shade has been produced, it is sent to or it is displayed in a shop. And then when users is using this shade, of course the user or consumer need to pick up the shade from the shop with his private car. So we also include the transportation of 5 kilometers to the shop and back to their homes. And then after the using of shade, after many years, so the shade has broken down. So we also consider the end of life of the shade where it is being disposed. So in this exercise, we will consider two different disposal method. One is open burning, open fire, and another one is inert landfill, means it's thrown into the landfill. So whatever activities that we are considered are actually compiled and grouped within the boundary. So whatever which is not inside the boundary is not considered. Okay. So like we said, like I have mentioned in the previous class, the environmental impact is calculated based on the transport or the input and output from the investigated system boundary. So in this case, we are actually calculating the total fuels used or the total energy used, either from electricity or from material, from energy, from transportation. Everything is already included or have to be included. And then on the emission to the environment, we will compile. We also include, especially during open burning or during transportation or during burning of wood in the factory. So we are actually modeling all these activities, and we also model the input and output of each activities. So in this case, what we are going to do is we are going to model the production of the shade first, which is in green. Then secondly, we are going to model the disposal of the shade, which is in yellow. So once we have these two activities modeled, and then we will combine them together to make it as a life cycle of the shade. So this is basically what we are going to do today. Okay, so first we will look at the green color one. So we are going to look at the production first. Yeah. So on the green color one, imagine I have tried my very best to get all this information, primary data from the manager of the factories who produce wood plank. So this is what I got. So let's have a look at this flow chart first. So in order for us to produce a shade, we need a plank, a wood plank. So where do we get the wood plank? We got the wood plank from a sawmill. So sawmill is the place who produce wood plank. So once we visited this sawmill, we found out that this sawmill is not only producing plank, it also produces sawdust and bark in the ratio of 50%, 40%, and 10%. So to produce this, they need to have some or a number of inputs. Examples, electricity. For every ton of wood plank or produce, it requires 150 kilowatt hours of energy. So this is actually primary information. And then on the energy production, that one is secondary. We call it a secondary database or secondary data. All right. So to produce 1 ton of products, so they need a tree which is felled from the forest, 1 ton, and this tree has to be transported from the forest to sawmill. So we are actually investigating upstream. All right. So to get this felled tree, 1 ton transported to the sawmill, so we get a transport of 200 kilometer. So let's check on the felling tree activities, which is upstream. So to fell 1 ton of tree, it actually required, maybe a wood ranger to fell 1.25 ton of tree, and then they estimate about 250 kg is actually wasted. Examples: the leaf, the branches, the twigs, which are not able to be used to be produced as plank. So to fell one tree of 1.25 ton, it requires about a chainsawing process of 3 minutes. So of course, chainsawing process, we will include also the diesel consumption during chainsaw, and also the exhaust emissions from the engine also will be already included, but that one we will rely on secondary data. All right. So now next what we are going to do is we are going to model 2 processes and link these 2 processes together. First, I will model the felling of tree. Secondly, I will model the sawmill. And once I'm modeling the sawmill, I will link the felling tree to the sawmill, which is this one, the product, the economic product, felled tree to sawmill. All right. Okay. So without further ado, let's go straight to our SEMA Pro software. So in the SEMA Pro software, what you need to do is you need to actually open a project. All right. So a project with a tutorial with wood examples. I think you have this project. You just need to click on it and open. Okay. So once you open the project, you have got all these things in your we call it on the screen. Okay, so first of all, the first thing is to write the goal and scope and the scope. So first, this one is already prepared for you because this is actually a by default one. So it already tell you what are the functional units and the reference flow and the goal of it. So for this exercise, the scope has been very limited. For instance, we disregard the maintenance, lifetime. So this is what he already mentioned. So if you are creating a new project, remember all this will be empty. So you have to fill this up yourself, okay, based on your own scope, design, and your system boundary, your reference unit, and also your goal, okay? So let's go straight to the processes. Since this is a new one, so it is not actually like demo one where the coffee machine examples where the processes is already inserted for you. So in this demo too, you will need to create the process on your own. So to create the process on my own, I need to find a proper destination of my processes. Okay, of course, you can put your processes anywhere you want, but to make things more systematic, so I would rather create this under the folder of wood. Okay, so if you look at my library, I have already a few existing processes there. All right, that's because I already included some of the libraries which is free. I think also have that library. So I would create the processes under wood, okay, material of wood. So I click on the wood, I highlight it. So I will click on the button new. So this box will pop up. Okay, so a new template will pop up. So of course, I do not go, if you click, there are 4 buttons here: documentation, input, output, parameters, system description. All right, so for the documentation, I do not want to elaborate further. You can go and key in the name and whatever information is needed, examples, the source of your data, and when you get your data, who is your interviewee, something like that. Okay, this is not mandatory, this is not necessary, because all this information will not be reflected in your analysis. This is just for your own references. So in this exercise, I won't complete this documentation part. So I will jump straight into input output table. So every processes, I will jump straight into input output tables. Yeah. So in the input output tables, you will see there are actually 3 main part section. The first section is product. If you look at this word product, so there are product. The second section is on the input, and then the third section is on the output. So there are basically 3 main sections. All right, so I'm going to insert the first failing of 3. So if you look at this model, the first failing of 3, so the product of this exercise or this process is actually a failed tree. So here I'm going to key in the output to technosphere, which is the product and the co-product. In this case, the product is failed tree. So I'm going to double click on it and I just key in failed tree. All right, and this is 1 ton, so I will just put 1 and click on it and I will choose TON, ton. So I already model 1 process. I'm starting to model 1 process, and this is the output, which is the failed tree. Okay, so to get the failed tree, of course, the whole process, there is input to this process, which is the wood from the forest, 1.25 ton. Okay, so now let's jump straight into the input section. Input section, basically, there are 3 categories. One is input from nature. The second one is input from technosphere, which is materials or fuels. And the third one is input from technosphere, which is electricity or heat. So remember, whatever which is virgin means it's coming from the ecosystem, coming from the nature. So you have to fill in the first column. Then the second column is for input from in terms of material or fuels. All right, and the third one is on electricity and heat. Okay, so the wood 1.25 ton definitely belongs to the first one, input from the nature. So what we need to do is double click on the add, then this message box will pop up, and then you can scroll up and down, and then basically these are every raw material that we can ever find in the environment. So there are water, transformation, and then some chemical substances, oxygen. There are a lot, okay, thousands of it. So what we need to do is we just need to scroll it down to wood. So WOOD, so wood. So we find the most appropriate one, wood unspecified standing in kg. All right, so one you highlight on it and then we select. So these things wood will appear in your column, input from the nature, and according to our model, it requires 1.25 ton to produce 1 ton of felt tree. So here we will put it 1.25. Okay, if let's say alternatively, if you do not want to change the unit, you can actually put 1250 kg. It is okay because the software can detect and calculate accordingly. So basically, I have already modeled or created a process where a product of felt tree 1 ton and the input of wood, which is 1.25 ton. So the second thing is the chainsaw process. So 3 minutes of chainsawing. So to get this chainsawing, okay, so which it is an input, all right? So we still have to put it in the section of input. So basically, which part that we need to fill it in, all right? So in this case, we'll fill in our chainsawing in material or fuels, okay? So you double click on it. You can try and error if you couldn't find. So chainsaw is a processing. So chainsaw is a material, but chainsawing is a process. So that's the reason why we have to carefully we call it locate our processes every time so that it is easier for us to find. So chainsawing is a processing, so I might find it from this processing folder. So because this is already being created, so I know where it is. So when I click on wood, so this is a chainsawing. I can find a few more, but because here this is just an example, so I will just uh, create or select chainsawing by default. Okay, and then we select this is a chainsawing. So since it is 3 minutes, so I will change it to minutes and put it 3. Okay, basically this chainsawing comprises a lot of upstream activities already, or like diesel and the emissions. So there's a reason why once we have put in chainsawing here, we do not need to put in the diesel required because it's already included. If we still put in diesel required, and then you will have the chance of double calculating. Okay, now we also know that in these processes, it produced 250 kg of wood waste. So wood waste produced means it is an output. So we have to scroll down output, and because this is a waste, final waste flow, so we just click on it. Then we scroll down until we find wood waste, and then we select. So it's about 250 kg. Okay, once we got this ready, you can actually save the things. If you do not save, and then you just cross, it will ask you whether you want to save it or not. Of course, you will say yes. So once you save it, the felt tree is already here. All right, I would like to bring you back to the chainsawing just now, because I said chainsawing already include the upstream activities of the chainsawing. So let's investigate. Okay, so if because just now I said our chainsawing is in the folder of processing. So now I'm selecting, let's inspect what is inside a chainsawing first. All right, so we double click on it. If you look at this chainsawing already include petrol of this much, and then light fuel oil of this much. So now you already know how to inspect or analyze or understand input-output template here already. So in this case, this is a chainsawing process of 0.025 hours. This is the product, okay? The activity is the product. It required an input of a petrol of 0.0166 kg, a light fuel oil of 0.0067 kg, and during the processes, the emission to the air is this much. It covered sulfur dioxide, nitrogen oxide, carbon dioxide, carbon monoxide, hydrogen carbon, and soot. So these are actually the chainsawing, and it does not include the material or the machine construction, a development of the machine. So in this case, we know that the chainsaw spare part, the development, the fabrication of the chainsaw is not included, and we are not including it as well. So once you are doing this, actually you understand your scope already. If you want to include, then you can go and search for chainsaw, spare part, this and that. It will be a very, we call it a comprehensive modeling. But in this case, we just model up to our own capacity, whatever we know, that's all. So now you understand that all these input and output already been included into your felt tree activities, okay, because you have choose this chainsaw. All right, so if you want to look at the other chainsaw, we actually can have a look at it. Okay, the second one, if let's say I am opening this up but double clicking, so it's like chainsawing 1 hour, and then in this 1 hour of chainsawing, so it required a gasoline of 0.23 liter. And this one, it does not include the emission to air. It only model the fuel required. So next time we would like to choose, before we choose, we have to click into it and we study the input output table, see what is already included and what is not included. All right, okay, now just now we have already completed our first activities, which is felling a tree. Now we need to complete the second activities, which is the production of plank. So I would like to create this process and locate the process in the material, because plank eventually is still a material. So I will locate it at under the wood, okay, together in the same folder with felt 3. So I highlight the wood and I click the button new. So in this case, again, pop up empty template. So first of all, I have to put in the outputs first. So for this sawmill, the outputs will be plank, sawdust, and bark. So in this case, because it enable you to put in more than one output, so we are going to fill in these 3 output together. So example, plank, and then click it on it, sawdust, and then click on it, bark. Okay, so in this case, because we know that there is a location given, 50%, 40%, 10%. So here I will put it as 50%, 40%, 10%. Okay. So here, if let's say we are putting a 1 ton as a reference, okay, 1 ton as a reference. So on 1 ton, 500 kg is for plank, 400 kg is for sawdust, 100 kg is for bark. So the system can automatically detect that the reference unit that you are referring to is 1000 kg, because all these add up to 1000 kg. So now we already put in the output to the atmosphere, which is the product. Now we have to come to the second section, which is the input. So we start one by one. The input from electricity per ton, which is 150 kilowatt hour. Since our reference unit is already 1 ton, 1000 kg, so I will just input, fill in the input of electricity of 150 kilowatt hour. So electricity is from the third input, electricity or heat. So I click on here, add. So I will find from the folder of energy, because electricity fall into the energy. Okay, so electricity, so I will choose, because I do not have much information about what is the source of the electricity. Either it's hydroelectricity, or it's from solar, or it's from biomass, we do not know. So in this case, I will choose electricity by country mix. I don't know whether we have it or not. So I'll just browse through. So in low market, see whether we have anything. Okay, so if I click on every folder, it will show me electricity from aluminum smelting, from bauxite mining. So a lot of this available. So what I will choose something. Okay, so medium. I'll go to medium, because when we're doing sawmill, we couldn't have a low voltage. So we'll go to medium, and then I will choose Malaysia if we have. If we do not have, so okay, so I will simply choose one. So electricity grid means we will choose the most appropriate one. So at consumer, okay, in this case, all right, in this case, I think I will choose any one, because they are almost the same. So I'll choose one from here and then select. Okay, so because this is megajoule and then this is kilowatt hour, we can change it to kWh. Okay, kilowatt hour. So the kilowatt hour, which is 150. So this is what, of course, if let's say when you are playing with your demo version, you might not necessarily be choosing the same electricity from me, because what I'm doing now, actually, I'm relying on the database to provide me secondary data of the electricity generation. So you can choose from your library, whatever electricity you have, you find the most appropriate one, and then you just click it in and you insert this kWh. Of course, eventually your result and my result will be different, but I don't see much, a huge difference between us. It's difference maybe between the source of the electricity generations and the efficiency of the technology in the power plant. Okay, so you can choose, you are free to choose any other kind of electricity uh, secondary data, and then you just pick up the one that you think is most appropriate. Then you select and then you put in the value 150 kilowatt hour. So I've already done 3 products and then one electricity in. And then the second thing is the felt tree. Okay, it's very important because this is one step to actually link my felling tree to sawmill. Okay, so the felt tree is bacterial, so I will have to add my felt tree into the second input. So I double click on it, and now I know, like I say, it's very important to know where I located my processes that I created just now. I created and I put it under the material wood. So my felt tree, I just click on the felt tree. So it required 1 ton of felt tree, okay, to produce, to be changed into plank, sawdust, and bark. So 1 ton of input of this produce 1 ton of output of that, of these 3 components. Okay, and the second things of input is the transportation. Don't forget, the felt tree has to be transported to sawmill, which have to undergo a journey of 200 kilometers. So in this case, the transportation will put it under the input of material and fuel. So we double click on this material and fuel, double click on the add, okay, and then we will go and find from transport. So because this is a road transport, so we'll click on the road transport. Then there are a few choices that we can choose. Again, because we are relying on secondary data, so you also can choose any secondary data that is available in your library where you consider is the most appropriate. Okay, so in this case, because this is a truck, a long haul, so I'll use a truck, a combination truck, long haul diesel powered, something like that. Okay, so I'll select. So in this case, because it is 200 kilometer, if you notice that the unit is TKM, TKM is ton multiplied by km. So in this case, because we are considering 1 ton and 200 km, so it is actually 1 times 200. Okay, just to let you see. So 1 ton and undergo 200 kilometer, so it's actually 1 times 200, which is equal to 200 kilo TKM. Okay, so we have completed 3 products, 1 input of electricity, 1 input of felt tree, 1 input of transportation, and okay, and another input is actually the wood waste, okay, 250 kg. In this case, we actually do not put here, you know why? Because when we are putting the felt tree, the wood waste is already included in the felt tree activities, if you remember. So we do not need to key in any wood waste here anymore. If we key in, it will be double calculated. So now what is lacking behind, or what we have not included, is the emission to the air. So because the wood waste is used to burn and to dry the plank, the sawdust, and the bark. So during the open burning, so this, because sawmill, you know this, there is no air treatment processes. So all pollutant is being released to the environment. So we get some primary data from DOE, Department of Environment, regarding the open burning. So this is some of the common substances that to be released when open burning is carried out. So in this case, we will put it in the third section, which is the output, and all this, because this is going to the air, so we will fill all these components into the category of emission to air. So what we need to do now is we just double click on the add, and then we have to find carbon dioxide. So you just need to scroll up and down alphabetical order to find carbon dioxide. If you want to be quick, you can just type carbon dioxide and then it will come out. So carbon dioxide, biogenic. Okay, because this is a wood waste, so a biogenic means it's from organic material. And then I will insert one by one. Carbon dioxide 450 kg. Okay, So in this case, 450 kg. The second one is the CO, carbon monoxide. Double click. Carbon monoxide, I think it is here. Carbon monoxide is biogenic. So select. Then carbon monoxide is 2.9 kg. The third one is NO2, nitrogen dioxide, NITROGRN. Okay, when I type nitrogen dioxide, it will help me to automatically select here. Okay, nitrogen dioxide. So it is 500 gram. 500 gram. Okay. The next one is PM10, particulate matter. So we just need to, okay, so particulate matter, so smaller than 10, all right, select. And then here we're putting 540 gram. Okay, 540. So I'll choose gram. Okay, and then the last one is SO2, sulfur dioxide. Double click on it. Sulfur dioxide. Okay, so click on it. It is 100 gram. Okay, so that's all information that we have done. So basically what we have done, we have compiled all this information into the processors. Of course, you can do more. So at this stage, these are the main important things that you need to know. The rest, you can explore it further. Okay, so let's revise what we have done on this second processes. We have included three main products. Okay, we have included the input of the felt tree and the transportation of a felt tree to the sawmill. We also have input the electricity consumption, which is 150 kilowatt hour per ton. Then we also already modeled the emission to the air due to the burning of the wood waste to dry the plank, sawdust, and bark. So we included all the chemical compound which is released to the environment during open burning and their respective magnitude or the concentration. 500 kg, 2.9 kg, 500 gram, 540 gram, and 100 gram. Remember, all these are actually relevant or associated to a reference unit of 1 ton of felt tree to sawmill. Okay, once we are done, we just need to click on the cross and then a pop-up message will ask you whether you want to save the change data. You will click on yes. Okay, so when you click on yes, and you will notice that you have already created a felt tree and also three product, which is bark, plank, sawdust. Despite you have these three products, when you click, it will link you to the same input-output table. Okay, so now we have already done with the first part, which is demo 2.1, modeling the production of wood plank. Okay,